In this video, we're going to prove this theorem. This is one of DeMorgan's laws. Um, it's one of the neither nor laws, you could say. It's one of the theorems that says that these are two ways of symbolizing neither nor. So we'll construct a derivation to show that if this is true, then this also has to be true. So I've already set up the basics for the derivation here. Right, I've put the theorem down at the bottom of our table and already introduced, put in another column here for the subderivation that we're going to need to introduce. So this is a conditional. That's the form of this sentence. So we're going to use conditional introduction to get it. It's not that to be. Okay. So for conditional introduction, we need a subderivation with the antecedent as an assumption, and then ending with the consequent. I mean, technically, subderivation doesn't have to end with the consequent, but once you've got the consequent, there would be no point in continuing the subderivation. Okay, so looking at what we have at the top here with this assumption, that's a negated disjunction that we have nothing to work with there. There's absolutely nothing we can do with that sentence. So let's look at the bottom here. This is our goal sentence, not A and not B. This is a conjunction. And so the way that we can get this is with conjunction introduction. So we could derive this by conjunction introduction if we had not A and not B. So we'll write those into our derivation, and those will be the next pair of goal sentences. So look at not A first. This will be our next goal sentence. This is a negated sentence letter. And given that it's a negated sentence letter, we talked about this in an earlier video. The best bet for deriving this is going to be just negation introduction. So we'll set up to do that. We'll add in a new subderivation here where we assume A for negation introduction, write in the rule down here that we're going to use. Okay, so now we're in this subderivation down here, trying to use negation introduction. So what we're looking for here is we need a pair of sentences where one of them is going to be the negation of the other, right? We want the pair of sentences that's going to be of the form Q and not Q. And at this point, we're kind of working top down, right? I mean, we don't have an explicit goal sentence that we're looking for. Um, but when you're trying to find a contradiction, you generally don't want to try to find two brand new sentences that are going to contradict each other. What you usually want to do is you want to look at the earlier lines of the derivation and try to find the opposite of something that you already have. This is almost always the most efficient way to do it. So far, like earlier in the derivation, what we have is not A and not A or B. So we would want to find the opposite of one of these two lines. Um, that finding the opposite of that is, I mean, that's what we introduced this assumption to do. So that's probably not going to be a great strategy. But this here, for this, we would the opposite of that would be A or B, and that we can actually get. Right, we can get that from A by disjunction introduction. Right, we go A or B by this will be from line 2, disjunction introduction. And then we just reiterate line 1 from 1R. And this subderivation is complete. So we've now proved this line here, not A, by negation introduction. And you know what? I can actually just cut this. We'll move this up here so that it's right under. We don't actually need to do this. I think it'll be a little bit easier to read if we just move that right under the subderivation. It's not strictly necessary. It's just going to make things a little bit clearer. Okay, now for this sentence here, we're just going to do pretty much exactly the same thing, right? We'll get it using negation introduction. And so we'll be assuming B for negation introduction. Oh, we need to, oh no, wait, we don't need to leave a blank line there because we will have that between the two. And then we will get A or B by disjunction introduction again. And then we will reiterate 1. And we have our contradiction there. We'll just fill it in this scope line. Oops. And there, this one is just 6 to 8. Negation introduction. We didn't use any of these lines, these rows, so we're just going to delete them. This is now line 9. This is line 10, and we can fill in these line numbers. We got it from lines. Well, it doesn't matter what order we put them in. Lines 8. Oh no, wait, that's not right. It's lines 9, 9, and 5. The order that we put them in really doesn't matter. And then 11, and we got this by 1 to 10. And our last step, which I'll probably skip in the video because it's boring, we'll just be writing in this, drawing in this scope line. And so this derivation here is complete.